Now, refraction of prism. What do you mean by refraction of prism? Prism is a triangle shaped glass structure, right? We have seen that in our labs. So what is so special about refraction from glass prism? See, we know that this is denser medium and outside it is rarer medium. So once a light ray which is incident on this surface, first I'll draw the normal because that is what I have to follow. Ray going from rarer to denser will bend towards the normal. So instead of this point that the ray was supposed to go like this, it will bend towards the normal. Now on this surface there will be a second refraction, right? Instead of this point, fact that the ray was supposed to go like this, it will bend away from the normal, so light ray would go like this. So that is why refraction happens. Now why are we studying refraction from prism? Because this is not the only thing which happens. There is another phenomena which is associated with refraction of prism, that is called dispersion. What is dispersion? First see, before I go to dispersion, first see how the images is formed in the prism. This is what I draw, right? The actual ray was this, whereas emergent ray, this is the original ray, this is the emergent ray. So if I extend this at the back, I'll get this is the angle of deviation. This is the minimum angle by which the rays are deviated when it has passed through this prism, right? Now why we are studying this, as I told you that there's another phenomena associated with diffraction of prism which is called dispersion. Now what is dispersion? According to definition, dispersion is splitting up of light rays into its constituent colors. Now how does that happens? Actually, refraction or refractive index, which is denoted by n or mu, so don't consider it as n upon mu, it is any one of the thing, I'll write just mu. Refractive index is actually inversely proportional to wavelength. What? Wavelength. Now what is wavelength? See, light is made up of both electric and magnetic fields. Okay, I'll give you more simpler thing. What is wavelength? Light travels in the form of waves like this, right? This crust and trough, the distance between any two consecutive crust and trough is called wavelength. What are the other things? This is called amplitude, and time taken to cover one complete cycle is called time period, and 1 upon time period is called frequency. These are four things always associated with any of the wave. Number one, wavelength, the distance between two consecutive crust or two consecutive trough, or the length of one complete wave, that is wavelength. Maximum height or the amplitude, then time to cover one complete wave is called time period, and reciprocal of time period is frequency. So light is actually a wave, right? Light travels in the form of waves as well, and refractive index is inversely proportional to wavelength. We know that white light, which helps us to see, is having wavelengths from 4000 Armstrong to 8000 Armstrong. What is this? Is a general rough idea. 4000 Armstrong, this is not the exact value, it is somewhere 3892 something, 279 something. Okay, anyhow, this is a rough idea that 4000 Armstrong is 4000 into 10 raised to power minus 10 meters, or 4 into 10 raised to power minus 7 meters, to 8 into 10 raised to power minus 7 meters. This is the wavelength of white light which helps us to see. So which color has the maximum? We already know that light has how many colors? 7. VIBGYOR, that is Vibgyor, violet, indigo, blue, green, yellow, orange, red. Red has the maximum wavelength. Remember it like this, red has the maximum wavelength, and that is why red is always used for the danger signals, because due to maximum wavelength, red can be seen from a very long distance. So red has this maximum wavelength. Now as I told you that refractive index, or the intensity or the amount of refraction or the amount of bending which light is going to suffer will depend on the wavelength. Higher the wavelength, less will be the what? Refraction. More the wavelength, less will be the diffraction. So suppose this is our prism, white light is entering from this point, this is my normal here. It was supposed to go like this, but due to refraction from first surface, that is rarer to denser, it will bend towards the normal. Now which color will bend towards the normal? More will be violet, and red will bend towards the normal less. So instead of a single ray like this, light got separated into its constituent colors, because red color got minimum deviated and violet color got maximum deviated. Again, on this point as well, two refractions will happen. This, instead of going straight, will suffer more refraction, while this going like, supposed to go like this, will suffer less refraction. So this is how light gets converted or gets splitted into its constituent colors. So that is what dispersion means, splitting up of light rays into its constituent colors. Which color will be maximum deviated or maximum seen? Violet, indigo, blue, green, yellow, orange, red. So violet gets maximum deviated, whereas red gets least deviated because of the wavelength. So this is how it looks like. Different colors get dispersed from the prism, and this whole thing is called dispersion. Now the next thing, the same principle acts in our atmosphere when light gets dispersed by small water drops which are present or which remain suspended in the atmosphere or air after rain. See, in rainy season, it's a lot of moisture or water vapors, or you can say when small water drops are suspended in the atmosphere, what will happen? The refraction of white light or sunlight will happen in the atmosphere itself, and that will result into this scenic phenomena which we call the formation of rainbow. How does that happen? A ray of light which enters the water drop or the suspended drops, very small, it gets first of all refracted from this point, and then and there only the dispersion starts. There is another thing which is called total internal reflection which happens on this part, and then light gets more dispersed from this part. So this is not, we have shown you only the one sphere or one spherical water drop, but actually there are millions of small suspended water droplets, and that is why all the lights get dispersed at the same time, and hence they combine together to give this phenomenal view of rainbow. Now, is there anything else which happens due to atmospheric refraction? Yes, there are a lot of phenomena. For example, this thing, the glittering or the